Alright, so we saw what are semaphores and we had a quick look at how they work. So there are a couple more points I would like to drive home before we move to the next topic. First is, if you look at this wait function or the definition of the wait function, it says while s less than equal to 0, busy wait. Now you saw that your semaphore is initialized as the number of resources available. So the initialization is always a positive integer. You cannot have -5 printers, for instance. So it is, when it is initialized, it's always going to be a positive integer, and every time a process comes and sees that resources are available, they're going to take up one instance and decrement it. So let's say your initialization was 5, then 5 processes can come and take up one instance each, and 5 times the decrement happens, and let's say your s becomes 0. This is perfectly possible, capable of happening, makes sense. Now when your 6th process comes and it calls the wait function, you see while s less than equal to 0. Note that the current value of s is 0. So this function becomes true because s is equal, this condition becomes true because s is equal to 0. So it is busy waiting, and this waiting stops only when someone else signals the release of one resource. So only when s becomes a positive integer again, only when s becomes at least 1 again, does this waiting stop, and this 6th process can claim the printer or whatever resource. So what I'm trying to say is, when your s becomes 0, no one else is going to be able to claim the resource until it at least becomes 1 again, which means your s can at most take the value 0. It cannot go less than that. It is not going to become a negative number ever in this implementation. So if you look at this, this is a logical implementation of the wait function. This is not exactly how it is hard coded in your operating system, in your CPU. So but logically this is the idea, this is the framework. So according to this algorithm, your s is never going to be a negative number. So it is initialized to the number of instances of the resource you have. The smallest value it can take is 0. It is never going less than that. So if you were wondering what does s being negative mean, s is never going to be negative in this logical implementation. But there are specific implementations, as you will see here. There's a wait function here, there's a signal function here. There are specific implementations written in specific programming languages using which are specific to your hardware, your system architecture, and so on. There the definitions are slightly different, so there it is possible for the semaphore to take a negative value. However, for the purposes of this course and this discussion, all we need to know is the logical idea of a semaphore, which is very similar to that of a mutex lock. The only difference being semaphore has an unrestricted domain and is not a binary entity. So we will stick to this definition of the wait and signal functions, and as far as they are concerned, s is never going to take a negative value. That is the first point I wanted to make. Now secondly, you have a wait function, you have a signal function, and it is not very difficult to fathom how they are going to be used. So let's say you have 2 processes. P1 is going to signal the semaphore. So in this case, they are calling the semaphore sync. In the previous example, it was called S. It's just a matter of name. You can choose to call it whatever you want. So P1 is signaling. P2 is waiting. So once this signal is received from P1, meaning once P1 has released whatever resource it was using, then P2 will be notified and it will take up the resource and continue, right? This is what we saw. But now the question is, how does P2 know that P1 has released? So we see while s less than equal to 0, you're waiting, and then once this while condition breaks, once the value of s has again become a positive integer, then you're allowed to make a claim. So how exactly does this process know that some other process has incremented s, that some other process has released a resource? So for that, we have something called a wake up function. If you look here, the process is restarted by a wake up operation, which changes the process from the waiting state to the ready state. Or if you look here, when a process must wait on a semaphore, it is added to the list of processes. A signal operation removes one process from the list of waiting processes and awakens that process. So what am I talking about here? I'm not going to go into the code version of these wait and signal functions, at least not in this discussion. My point is only that when a process P1 releases or signals the release of a resource, there is something called an inbuilt mechanism called a wake up function, which is going to notify the other processes which are waiting. So that is how a P2 which is waiting comes to know that P1 has released this printer, so I can take it up. That is how P2 is going to be able to access this. So these are the 2 points about semaphores which I wanted to convey. In the next segment, we'll be looking at the next topic.